Okay guys, in this tutorial what we're going to do is we're going to use the millis function to control a program by time, by the system time, or actually how long the time's been running. We're going to change states based on the time, and we're going to do some counting using a counter based on a timer. The circuit I have right now has 2 buttons and it has 3 LEDs, so that's the basic circuit I'm using. So millis is the function we're going to use today. And what it does is it returns the number of milliseconds passed since the Arduino board began running the current program. So, for example, if it returned 1000, that means the program was running for 1 second. It'll go into overflow if it runs for 50 days. So that means after 50 days it'll go back to 1000, right? You can figure out how many milliseconds 50 days would be if you were to figure out how many seconds are in 50 days and then multiply that by 1000, which we're not going to do right now. So this is kind of how we're going to use it here. We're going to use time equals millis. There's no parameters. Here's a simple example of what's going on. So it's just going to print out the time. So what we're going to do is we're actually going to use this program and we're going to see how this thing works. So let's go ahead and get started. What we're going to have to do is copy this. We're going to go ahead and go to Arduino. Now we don't need this for now. We're going to do this for a little bit later. Okay, so again, this opens up the serial port, and this will say like time, and then I'll go ahead and put in your time. So the reason why we don't put in a println is so it doesn't go to the next line, and this will go up by every second. So if we go ahead and run this, or I'm going to call this time sketch. Okay, let's open up the serial monitor. Okay, so you see it's not exactly 1000. Some of these, a little bit off. Could be off by 1,000th of a millisecond, which is fine. Now what do we do if we want to find out actually how many seconds it's been running? Well, we could take this and divide it by 1000. And that will go ahead and do our time. Go ahead and verify it. So now what we'll do is we'll get 1 second, 3 seconds, 3 seconds. Now the reason why it's doing this is if you look at the code, you notice it says time. If we say this, double time, so this will actually allow it to store a decimal. And now we run it again. Okay, it's still cutting it off, so you might have to do something like this. 0.00. Alright. Sometimes when you mix an integer with an integer, you don't get the decimal. So it seems to be working pretty good here. It's more accurate now. Okay, beautiful. So as you can tell, this will give us the time. Not a big deal. You didn't even need to do this. It doesn't really matter. So now, now that we have this information, excuse me, what can we do with it? Well, what I'm going to do is I'm going to go ahead and get rid of this. I'm going to keep this, but I'm going to get rid of all this stuff. I don't need it. And I'm going to come up here and I'm going to go ahead and set up my pins. So let's see. I have a blue LED, and my blue LED is in pin 10. And then I have int button 2 pin, and that is in, that's in 8. Okay, so I have 1, 2, 3 LEDs, 2 buttons. I have everything defined, and I'm going to define something called string state. You're familiar with this. Equals, we'll call it red. Okay. And what we're going to do, it's kind of simple. What we'll do here is every 10 seconds, let's not wait 10. Let's say every 5 seconds. And we're going to do one more. Hold on. We have to call this old. Can't put time because that's reserved. Old time equals 0. Okay. int new time equals 0. I'll explain how this is going to work. And we'll do every 5 seconds. We will blink, let's just say, let's just blink the red light for now. We'll make it easy. Okay? So what we're going to do is we're going to say this. We're going to say if let's actually do this. New time equals millis. So what this does, get the current running time. Now we'll say if new time minus old time is equal to, now how many seconds did we want? We said 5, right? So 5,000. Let's say if it's greater than or equal so we don't run into any weird issues. If it's greater than or equal to 5,000, what do we want to do? We want to do this. Let's say, let's go ahead and blink our light. So we're going to say, we're going to digital write. I don't know, let's blink the blue one. Blue. LED pin. High. Then we'll delay by like 200 so you can see it blink. And then I'm going to copy and paste this because I'm lazy. Let's make it low. And let's go ahead and delay. So what's going to happen here is every 5 seconds, the light's going to blink. Now, what haven't we done yet? If you take a look at this code, there's something that won't work. What we haven't done yet is we haven't set up our ports. So let's go ahead and do that. We're going to say pin mode. Now, what pin mode do we need set up? Red LED pin. Right, these guys. Green LED pin, all that. Red LED pin, that's an output. Okay. And I'm going to copy and paste this. Green. Blue. Okay, so I have my red, my green, my blue. Let's do our button pins, pin mode. AJ, thank you. Button pin, and that'll be input. And pin mode, button 2 pin. Okay. All right, so those are all my pin modes are set up. Let's go ahead and verify this. And let's send it over. And what we should see is every 5 seconds, the blue light should blink. Okay. So what's happening is it's blinking, which is great, but it's not stopping blinking. So what we need to do now is we need to fix this. So what we want to do is this. So if new time minus old time is greater than 5,000, once this is true, like for example, old time is 0, right? It's going to start at 0. Let's say new time reaches 5 seconds, which is 5,000. Right? The next time it might be 6,000, 7,000. It'll always be greater than 5,000, right? So we need a way to sort of reset the old time, let the computer know it blinked, and then update it. So what we're going to do is this. We're going to say the old time equals millis. And what this does is this will set the old time back to the current new time, which basically resets the time. Like for example, once I hit 5,000, we're now going to set it to 5,000. And then this thing won't occur again until it's 10,000. So new time will be 10,000 minus 5,000, which will be, 5,000. And when I go in here, we're going to say, okay, now make this 10,000. So it'll go again to 15,000. So it's going to go every 5 seconds. So if we run this, you're going to see this work. Okay. And we're going to go ahead and upload this. And then if we watch it, we're going to notice that, okay, it's going to blink at 5 seconds and then stop. Right, it's going to wait another 5 seconds. It's going to blink at 5 seconds and then stop again. So what we might want to do here is let's print out some values so you can sort of see what's going on, okay? Serial.print. We're going to put new time equals okay. Then we're going to do that for old time as well, okay? And now we're going to say old time okay? So what's going to happen here is it's going to go ahead and print out, and we can actually delay this if we want. It'll print out pretty quick, but that's fine. So let's go ahead and upload this. And we'll look at our serial monitor. So once it hits 5 seconds, watch, 4, 5. See, now our old time is, I'm going to turn off auto score for a second. Okay, so do you notice, let's look up here. Let's scroll. Okay, so in new time, old time, new time, old time, new time, old, so we're going to hit 5,000. New time minus old time is greater than 5,000. What's going to happen is, all right, set the new time now to the current time, which is 5,040. That just happened to be that system time. And now keep going until what happens? Until this thing is 10,039. So if we watch, we're going to go. You can see this new time getting bigger, new time getting bigger, right? Old time is still the old time. New time getting bigger, new time getting bigger, new time getting bigger. All right? And right here is when it switches, because 10,442 minus 5,439 fulfills that 5 second thing. And then now we reset the new time to the old time to the current new time, and this thing's going to go again about 15, right? So if we scroll down here, 14, 15, right here. And now you'll notice they'll both turn 15. Right there, okay? So if we want to make this a little bit easier to read, we could do this. Instead of doing this, old time equals millis, we could just say old time equals new time, because that'll be the time that it switched over, and this will be a little bit easier to read. So let's do that. Okay. So we'll go. We could see it. Well, I'm going to turn off auto scroll here. So as soon as it hits 5,000, bam. You know, the old time is now 5,000. It wasn't exactly 5,000. So now it'll be 10,018 about. It'll switch over. So if you scroll down, so where are we? 10,031. There we go. That's our condition right there. 10,031. So new time, which is 10,031, minus old time right here, which is 5,009. That is in fact 5,000. So the light's going to blink, and then it's going to say, all right, we'll take old time, make it the new time, which was what we got from up here, and now keep updating the new time right up here. Just keep grabbing it, keep grabbing it, keep grabbing it, keep grabbing it. So again, let's turn on auto scroll, and we can watch it, right? So you can see it just scrolling by really quickly here. Right? And every 5 seconds, it's just sort of going up here. Every 5 seconds, right? Okay, so that's that. Hopefully you understand this and what millis does and why we do this, what this means. This gives us an interval. You could say something like interval here and use a variable, and understand why we reset the time so we could get a new 5 second interval. Okay, so hopefully that made sense, and I'll design some exercises where you guys could use this idea.